Okay, I have two sections combined in here, 8.7, which is factoring special products, and 8.8, which is factoring by grouping. First one, factoring by special products, the only one we're going to use is going to be difference of squares. Difference of squares is whenever I have, so here I have two terms that I can take the square root of both of, that is separated by a subtraction sign. So just like I have here, my example, 4x squared minus 1, the square root of 4 is 2, the square root of x squared is x, the square root of 1 is 1. So they're all things that I can take the square root of, and so what I can do is, again going back over here to the left, whenever I have a difference of squares, I can take the square root of both the terms, and then I can put them in two parentheses, one with a plus sign and one with a minus sign. So over here, again, I took the square root of 4x squared and I got 2x, took the square root of 1 and I got 1. 2x is going to be my first term in both these, and 1 is going to be my second term. Again, signs are always, one is a plus, one is a minus. So here, first thing I look at is, can I take the square root of x squared? Yes, I can. Can I take the square root of 4? Yes, I can, and a subtraction sign in between. So, I'm going to write out two parentheses. One's a plus sign, one's a minus sign. The square root of x squared is x, so I'm going to put an x in for my first term, and the square root of 4 is 2, and so I put a 2 in for my second term. And I'm done. Again, if I multiplied this out, my two middle terms here would cancel each other out and get me 0, so I don't have an just regular x term. Here, same thing, 4x squared. I can take the square root of 4, can take the square root of x squared. Can I take the square root of 25? Yes. Subtraction sign in between. And so then again, I can go ahead and do two parentheses, one with a plus sign, one with a minus sign. The square root of 4x squared is 2x. Again, my first term always goes in my first spot, and then 5 is my second. This one usually throws people for a loop. I'm just going to change the order of this. 25 is a perfect square, 49x squared is a perfect square. Plus sign, minus sign. Again, 25, square root is 4, it has to go in my first spot. Since it came first in my difference, I have to put it in first. Then my second one, I get 7x, and so I get 7x as my second terms. And then last but not least, again, plus sign, minus sign, 3x plus 12, 3x minus 12. And that's it. So, grouping by factoring, this is a little more difficult. The first thing that we want to realize is that the only time that I will do this is when I have 4 terms. So I've got x to the third plus 2x squared plus 3x plus 6. 4 terms, and so the only way I can do this is by factoring by grouping. So the first thing I'm going to do is group the first 2 terms together, first 2 terms and the last 2 terms together. Put them in parentheses. I always want a plus sign in between here, so if this was a minus 3x, I would do plus negative 3x. Next thing I'm going to do is I'm going to factor out the GCF of each group. X squared is the GCF of x to the third plus 2x squared. 3 is the greatest common factor of 3x plus 6. What's left in the parentheses, and this is the most important part, must be the same. I've got x plus 2 and x plus 2. They're the same thing left in the parentheses, and so I know I did it correctly. So then from here, what I can do is, once I know that I have the same thing in both these parentheses, I can write this in 2 different parentheses, just like we've done in the past. My greatest common factor goes in one parenthesis, and then whatever this is that is shared, this same binomial that's left in the parentheses, will go in my other. So I've got x squared plus 3, which are my 2 greatest common factors, and then x plus 2, which is what's the same in both these parentheses. And then that's it. Again, if I did the crab column multiplication, distributed, I would get what I started with, and that's good. So, again, with this first one, I'm going to put parentheses around my first 2 terms. I always want a plus sign in between here, so negative 9x plus 18 in my second set of parentheses. My greatest common factor, again, the biggest number that divides my coefficients, which is 1, and my smallest exponent, which is x squared. So I'm going to take out an x squared. That's my greatest common factor because I have coefficients of 1 and 2. And so then to find out what's left, I'm going to divide each of these terms by x squared. So I'll do x minus 2. Plus, And then what I'm going to do here is, again, greatest common factor. I've got 9 and 18, so the greatest common factor in 9 and 18 is 9. And then what's left in the parentheses would then be, divide these, negative x plus 2. What I've got to realize right now is that what I have in both these sets of parentheses are not the same. One's x minus 2, one's negative x plus 2. What we should be able to see is that x and negative x are opposites, and negative 2 and positive 2 are opposites. So if instead of doing taking out a 9, if I take out a negative 9, then I can get different results. So I take out a negative 9. Again, negative 9x divided by negative 9 gives me positive x. Positive 18 divided by negative 9 gives me negative 2. So again, what's in the parentheses are both the same, and that's what I wanted. I'll group my greatest common factors together in the first parenthesis, so x squared minus 9. And then my second parenthesis, I'm going to take whatever's the same in both these, which is x minus 2, and put it in my second set. There's actually one other thing I can do here. I can look at this x minus 9, think x squared and 9 are both perfect squares. I can take the square root of both those numbers and a subtraction sign in between, so they're a difference of squares. So I can rewrite this as rewrite this as 2 parentheses, so x plus 3, x minus 3, and then x minus 2. Again, all I did here was just take this x minus 9, turn it into x plus 3, and x minus 3. And there's the homework.